Howdy Unite, it's Mr. Crouch again, bringing you some more content on plate tectonics and volcanoes. So last lesson we touched on the risks and minimization strategies for plate tectonics. This lesson we're going to touch on the other half of our assignment and talk about the risks and minimization strategies for volcanoes. So follow along with this slideshow and let's get started. So before we get started with this lesson, we're just going to make sure that you guys have downloaded the worksheet for this lesson. So same as last lesson, we've got a worksheet attached to this slideshow. Feel free to follow along with the slideshow and fill in the worksheet as you go along. Alternatively, you can watch the whole video and then right at the end, fill in the information. Or if you're feeling brave, feel free to not bother watching the video and go ahead and answer your worksheet. So a little bit of revision before we start. So most volcanoes are located around the Pacific Rim, which is also the Pacific Plate rather, which is also known as the Ring of Fire. So the Pacific Plate is where the Pacific Ocean is, and it's the largest tectonic plate on the Earth. Now volcanoes form, a little bit more revision, when mantle under the crust builds up pressure and escapes out of the surface of the crust. And 75% of the world's volcanoes are located around the Pacific Plate, so that Ring of Fire that we looked at before on the previous slide. Now, there are 3 stages of volcanic activity, and you remember this from the video last week with Mr. Bizet. So we've got active volcanoes. Now, these are volcanoes that are either currently erupting or have recently erupted within the last, say, 100 years. We've got dormant volcanoes, and these are volcanoes that aren't currently erupting or haven't erupted for a while, but there's an expectation that they'll most likely erupt sometime soon in the near future. And then we've got extinct volcanoes. Now, these are volcanoes that have once erupted in the past, but are most likely never going to erupt again. And there are 4 main types of volcanoes. So we start off with the cinder cone volcanoes, which is a volcano example we see on the right. We've also got composite or stratovolcanoes. We've then got shield volcanoes. These volcanoes tend to be quite flat. And we've also got lava dome volcanoes. Now you can revise these a little bit by referring back to lesson 3 last week with Mr. Bizet. But this is just prompting you to remember what those 4 types of volcanoes are. So during this lesson, your learning intention is to learn about the different risks associated with volcanoes and some strategies to live with these risks. And the success criteria is for you to be able to identify risks that come about from the formation of volcano activity and to describe strategies that humans can use to avoid, minimize, or live with these risks and stay safe. So we're going to cover about 4 risks that are associated with volcanic activity. So last lesson we touched on the different kinds of risks for the different kinds of plate boundaries. This time around, we're just going to look at the generalized risks for the volcanic activity in general. There are specific examples of risks for each of the different types of volcanoes, but if you're choosing to do a volcano for your assignment, I'll get you to look into that on your own. So the first risk we're going to look at is lava. Now, lava is magma that has escaped to the surface of the crust, so it's magma when it's under the ground, and it's lava when it's escaped and comes onto land. Now, lava is very hot. It reaches temperatures between 700 and 1250 degrees Celsius, so very, very hot. And it can destroy the surrounding land, building infrastructure. So imagine putting your house in the way of really hot lava. It's just going to go straight through your house, burn it down, melt it, depending on what your house is made of. And if you've got anything living in the road as well, so if you've got plants or wildlife, even humans, lava plus those things isn't going to mix very well. The second risk we're going to look at is pyroclastic flow. Now, this is a hot avalanche of rock, ash, and gases, like really hot and compressed gases that travel down the volcano at high speeds. Now, this isn't things like lava. Lava is just the hot magma that's come up to the surface and is flowing down. Pyroclastic flow is essentially anything else. So all of your rocks, all of your ash, all of that gas that's coming down. Now, this is going to be very hot because it's being near the center of a volcano where there's that hot magma or hot lava. So it's going to be really superheated and it's going to destroy and burn everything in its path as it goes downhill. Now, in the event that the pyroclastic flow is mostly gaseous, so like say carbon dioxide, for example, that's going to remove all of the air that we need to breathe, and it's going to asphyxiate a lot of plants, or not so much plants, but people and animals that are in its path. So even if the heat doesn't kill you, you're going to die from a lack of oxygen, which is rather unfortunate. The third risk we're going to look at is landslides. Now, landslides are the movement of mass, like of rock, debris, or earth down a slope. So essentially it's like the side of the volcano is going down, all right, just crumbling and falling down. Now, when we talk about landslides with volcanoes, it can go in one of two directions. So it can go down the outside of the volcano, so away from the center of the volcano, or it can actually go into the volcano. That can cause another risk, which if you're looking at doing a volcano for your model, you can look into that yourself. But for now, we're just going to focus on landslides that go on the outside of the volcano. Now, these can destroy forestry and infrastructure in its path. So much similar to the lava flow that we talked about just before, landslides are filled with like rock and debris. Sometimes if it's wet, it can be quite fast going mud, and that's going to have a lot of speed behind it. So it's just going to barrel off anything in its way, taking it down with it. And you can see an example of that in the image on the right hand side. There's been a landslide, and that rock flow has just taken out all of the forestry and shrubbery in its path. Now, this can occur without even the volcano erupting, which is pretty unique. So sometimes with the volcano, there might be some earthquake activity that's happening nearby. There might be pockets of lava that are erupting within the volcano or moving within the volcano that cause movement within the Earth's crust, and that within itself can cause a landslide. So it's not just specific to a volcanic eruption. It can happen on its own independent of the eruption. Now, our final risk that we're going to look at is something called tephra. Now, tephra is the rock fragments that can be ejected from a volcano. So if you think about, say, Mentos in a bottle, for example, all right, when you put the Mentos in a Coke bottle, you're seeing that really big eruption, but sometimes you'll see splatters or chunks of that liquid going out and just spreading away from the bottle. Now, in this case here, tephra is kind of like that. It's not going to be that lava. It's going to be that rock and that ash and the little tiny fragments of solid matter that's going to be ejected from the volcano at really high speeds. Now, larger fragments can land. So like if you're thinking of things like big rocks, they're going to fly to the volcano at high speeds. They're going to travel away from the volcano and they're going to land in areas that are nearby. So these can cause massive damages. There's an example that you can look up online where there was a volcanic eruption and some of the tephra material actually launched a really big boulder and it crushed someone's car. So you can imagine if someone was in that car, they would have been crushed to death. Luckily they weren't, but in this example, it still crushed the car, unfortunately. Now with the smaller fragments, so we're talking about rocks that are less than about 2 millimeters in diameter, these can be carried away by wind. So a lot of it's still going to come down to the ground at some point, but it can be carried away in the wind and it can cause damage to locations hundreds or even thousands of kilometers away. So with that volcanic eruption, you've got all of that ash and you've got that smoke. That's going to cover things like sunlight. So you can have areas that are going to be quite dark, or they might have some pollution issues for a little while. And even if they get up into the atmosphere high enough, they can affect things like jet engines. So any planes that go through, if you've got lots of small rocks trying to go through an engine, it could damage the engine and ultimately cause further risks to people who are flying in the plane. So it might cause the engine to fail, it could cause it to crash or something along those lines. So when we talk about volcanoes, there's two main minimization strategies that we need to look at. So the first one we're going to look at is going to be the monitoring of the actual volcanic activity. Now, much like we talked about in the previous lesson with the tectonic plate activity, there's not a lot that we can do to prevent volcanic activity, much like how we can't really prevent the tectonic plates from moving. So a lot of this is more about minimization of risk and making sure that we're prepared for an eventual eruption of what could be a dormant or an active volcano. So when we're monitoring the volcanic activity, we can do this by monitoring the plate tectonic activity. So we learned last week as well, that when you've got, say for example, a continental and an ocean plate, and there's that subduction happening, we can see quite a little bit of volcanic activity right on the coastline. So if we are able to monitor that plate movement, we can sort of assess the landmass and the crustal area that we're working with and go, okay, maybe there's a higher chance of a volcanic eruption happening here because we know that there's going to be a subduction zone. We know that these two plates are converging on each other and there's a high chance that a volcano could erupt. The next part about monitoring volcanic activity comes about when you determine the level of volcanic activity and use that to assess the risk level. So this is going forward and looking at the volcano and going, okay, is it an active volcano? Is it a dormant volcano, or is it an extinct volcano? So by assessing those 3 criteria points, you can go, okay, if it's an extinct volcano, there's very low risk. Even though it might be near a volcano, there's a very, very minimal chance, if not almost a 0-point chance, that the volcano itself is going to erupt. If you're living near a dormant volcano, there's a chance that it's going to erupt, but there's less of a chance of it happening compared to if it was an active volcano. So you can use that risk level to determine if you want to build there, or if you want to do things in that volcano, say have tourism and stuff like that. You can assess that level of risk. And another minimization strategy, or rather technology, that we can use is aerial or satellite technology. So as we can see in the image on the right hand side, we've got an aerial shot of a volcano that has quite a lot of activity, so it'd be an active volcano. And we can use this to assess what's happening inside the volcano, especially those that have a large crater where we can see the lava or the magma in there. We can go, okay, we can see what's happening here without having to actually go up there ourselves physically. Now, the second minimization strategy that we've got in place that we can look at is actually having an evacuation plan. Now, like what we talked about with the plate tectonics last lesson, we can't really stop volcanoes from erupting. What we can do, though, is prepare for the event that they might actually erupt. So part of this is having a proper evacuation plan. So noting down if the volcano is going to be an active one, or it might be a dormant volcano, and having an evacuation plan in place. So working out what areas might need to be evacuated first, to what areas they're going to be evacuated to, how they're going to be evacuated, and taking that further and implementing warning systems, much like we were talking about last lesson with tsunamis. So ways to communicate with people who are near those volcanoes to go, okay, this volcano is going to erupt, or it might erupt, we need to get you guys out of here. So that could be in the form of things like texts, it could be in the form of things like sirens, TV broadcasts, a wide variety of different strategies that you can use for that one there. Now, these are only 2 of the minimization strategies that we can discuss here in this video. There are plenty more minimization strategies, and I strongly suggest that you go ahead and research those yourself if you're going to do a volcano for your model. But for the moment, after you finish watching this recording, or if you've been doing it as you go along, make sure you complete the worksheet that's attached to this lesson. Make sure you submit that worksheet to your individual Google Classroom so your teacher can have a look at it, and make sure you're also marking off your attendance for the lesson. And then once you've done all of that, have a crack at your assignment as well. So keep cracking it on with your model, keep doing a little bit more research. We've just touched on the risks and minimization strategies for both plate tectonics and for volcanic activities. That's 2 of the sections in your assignment. So definitely have a crack at that if you already haven't done so. But other than that, good luck with your lesson today. I'll see you guys on Thursday, where we're going to start to talk about a little bit of the plate tectonic theory that supports the idea of plate tectonics, and relating that to the risks that come about from plate tectonics and volcanoes. So until then, enjoy learning, Year 9.